All right, there we go. All right, so again, if I have just less than or just greater than, I'm going to put an open circle, right? So I put an open circle there, and it says x is less, so that means any number less, which is this way. So that's where I put my graph or my line. I go in that direction. And obviously the same is opposite. If I go this direction, and actually let's do this. Let's make this equal to, okay, greater than or equal to. Okay, so now, same number line, but now it's going to go the other way. So I put, not, oh, I'm actually wrong, right? Okay, it has equal to, so I put a closed circle, and then my line is going to go the other direction. Okay. Too much going on here. Let's fix up my markers here. Okay, now, for Friday, there's a Delta Math assignment where you don't just have one number in a variable, you have two numbers. So some of you guys might have got to that. So I'll go over that real quick. It might look something like this. Okay, so now you've got an inequality statement that's talking about a range of answers where there might be an end or there might be some kind of break in the middle, right? So here, if you look at this, and we got to understand what this means, x is, remember the fish? Okay, that means the fish likes to eat the bigger number, right? In other words, this says x is greater than 3. So that means the answer could be greater than 3, but it also says that x is less. It's less than 5. So that means if it's greater than 3 and less than 5, the answer is somewhere between those two numbers. Okay, so when I graph this, I've got these two numbers, 3 and 5. And again, I still follow the same rules. Okay, if I don't have an equal sign, that means it can't be equal, and I put an open dot. So open over both numbers, And it says that x is greater than 3, so I have my arrow going that way. But it also says x is less than 5. Now, some of you guys might think, oh, I just keep drawing my arrow going this way. But it says that x can't be less than 3. It has to be greater than 3. So I don't continue that direction. I actually stop right there. That's like, it's like a fence, right? It's like your teacher's like, hey, you can play to that fence and to that fence, but you can't go past that, right? So you have to stay in between. All right, and that's what this means, is that the answer has to be greater than 3, but less than 5, all right? So I also can't go all the way in this direction. So the answer is in the middle of the two. Okay, so it could be anything in the middle. It could be 4, 3.5, 4.2, okay? As long as the answer is in the middle. It also cannot be equal to 3 or 5, all right? You might also get something like this. Maybe it'll say x is less than or equal to 3, and x is greater than 5. So now when I graph this, I still have two numbers because those kind of define my limit, right? They define the limit of what my answer can be. And at 3, I have it's x is less than or equal, right? So that means that here I'll have a closed dot, where it says here x is just greater than, not or equal. So here I'll have an open dot. So they can be different. Okay. Now if you look here, it says x is less. So the answer has to be less than 3 or equal, which is this direction. Okay, because numbers less than 3 are to the left. So that means I'd have an arrow pointing this way. And then for the 5, it says that x is greater than 5. So I have an arrow pointing that way. So you see the difference. All right. Now, when you get to that Delta Math assignment tomorrow, or for tomorrow's assignment, it might just give you the graph that looks like this, and then you're going to have to type it out. Okay, or it might give you the graph that looks like this, and then you have to type it out this way. Or vice versa, it'll also just give you this inequality, and then you have to make the graph. Okay, it'll kind of go back and forth. All right. So again, that's when you're dealing with one variable, right? And you're just putting it on a number line. Another way to look at this one, because I know this one can be a little confusing, because especially if you're relying on the shortcut, like I told you guys about, like, oh, if it's pointing this way, I just go this way, right? If it's pointing this way, I just go this way. That doesn't quite work right here. Because if you think about it, at 3, if the arrow's pointing this way and the arrow's pointing this way, they should both be going that way. But this says x is greater than 3. So here's what you could do to this one. You could break it up. So if you got one that's like kind of combined like this, you have two parts to this statement. You have this x greater than 3, and then you have x is less than 5. Okay, so I'm going to take it apart. I have this one, x is less, or 3 is less. I'm sorry, x is greater than 3, or 3 is less than x, however you want to say it. And then I also have, oh, my bad, x is less than 5. Okay, so those, I basically took this and split it apart. Now this one you guys could probably see, because x is kind of on the left side, but this one is not. So what you could do to help yourself, just to help you understand it, is switch them. Okay, kind of like flip it around so the x is on the other side, right? But if you're going to do that, x still needs to be greater than 3. Okay, so now what you end up graphing is x greater than 3 and x less than 5. Okay, so that's one way to do it. Or if you're able to just understand that x is in the middle of these two numbers, that'll work too. Okay. Now, today's folder is about graphing on that graph, not on a number line, right? So how we graph here is you graph it just like any other line. And let me, where's my remote? Move this over just a little bit. Now we want to go this way. There we go. Okay, so when you're graphing, just want to make sure I'm still in the picture. On this plane, you're going to get equations that look like this, like 2x plus 3. Okay, y equals 2x plus 3. Now, if you guys remember how to graph that, you start at 3, okay, and then you use the slope to go up 2, because that's a 2, up 2, and then over 1. Up 2 over 1, 2 over 1, 2 over 1, and then I go back down the other way. Down 2, left 1, down 2, left 1, right? Just to complete the line. Now, I would draw a line with arrows on each end, and I'd be done. Okay, because that's all it asked me to do, is draw a line that says y equals 2x plus 3. So then if I asked you, what's an answer? What's a solution to that equation? You would say any point that's on that line. So like that point's an answer, that point is an answer, that point is an answer. Anything on the line is an answer to the question or to the equation, okay? Now, take the same equation and turn it into an inequality. Now it says y is greater than 2x plus 3. Okay, so now I literally graph it the same way. The graphing doesn't change. I still start at 3, I still go up 2 over 1. The only difference now is now we're going to have to define where the answers are by doing a dashed line, a solid line, or you got to pick one or the other, and then you have to shade it, okay, to show where possible answers are. All right, so now let's start with what type of line. Let's start with what type of line. It's greater than or equal. If you have an equal sign, your line will be solid. If you have a less than or just greater than with no equal sign, it will be dashed, okay? So here, this is solid, so I can just leave it the way it is. And then here, the next part is I have to shade it. Okay, so this is a part that gets it's kind of confusing for some. All right, so now it says y is greater. So if we look, if something is greater than something, that means it's usually above, right? It's on top, right? But the question is, what side of this graph is on top? Well, to kind of help you see that, okay, where arriba is, not abajo, okay? Think about it. This line is leaning to the right, right? It's leaning this way. And if I keep leaning the line like that, it becomes easier to see where above and below is. So if I lean this line like a little bit further this way, you could probably tell me where above the line is, right? Well, it's right here. It's on this side. Okay, now let's lean it back. Because as I lean it back and I increase the slope, it's still going to be over here. So now you can see that the above shaded area would be over here on this side, okay? So then what I do to complete my graph is I just shade this whole area. Now, if you guys are doing IXL, all you got to do is bloop, hit the button and it just like shades the whole thing, okay? Now, let's switch it up. Now, let's make it say less than. Just less than though, not equal, right? So first, let's go back to what kind of line? Well, now it's dashed. So the only change I make is that. On IXL, all you got to do is click the line, all right? Now it says less than instead of greater than, so now we shade below, abajo, right? We go below the line. Again, if I lean the line this way, below is down here, which means that this side is below the line, and I would shade here. Okay, so on IXL, just hit the button and you're good. Now, you might also get the question, well, after all that, what is an answer? What's a possible answer for this question? Well, let's go back here to kind of figure that out. If I was to ask you what's an answer, you would say, for this one, you would say anything less than 7. So like 2 is an answer, -2 is an answer, -100 is an answer, but 8, that's not an answer. 8 doesn't work, okay? Because it's greater than 7. So the answer has to be less. So over here, anything that's in the shaded area, that's an answer. So this point right here, 2 and 2. The x value 2 and y, that's an answer. Right here, right in the middle of the coordinate plane at 0, 0, because it's the area that's shaded, that's an answer. Okay? Now, what about over here? This is 6 and 6. Okay, what about that and that spot? Is that in the shaded region? No. So that is not an answer. So that wouldn't work. Next question is, what if it's on the line? What about this point right here? It's right on the line, right on the dashed line. And that's at 2, 6, all right? Question is that an answer? Well, if I go over here and I ask you, is 7 an answer to that question? Then you should say, no, it's not, because it has to be less than 7. It can't be equal to 7. So, because if you guys notice, see how this says less than? This also says less than without that equal sign, right? So it can't be right on the line. That's not an answer, right? But how could 2, 6 be an answer? How could that be an answer? Well, let's go over here. X is greater than or equal to 7. Could the answer be 7? Could you put 7 right here? Yeah, because 7, it's not greater, but it is equal, so that works too. So over here, if I change this to equal, less than or equal, well, now think about it, the line now becomes solid again. It's now solid, and because that point is right on the line, it works. So now it is a solution. So when the line is solid, okay, or has an equal to, your solution could be on the line. But as soon as I do this, and I don't have the equal sign, and it becomes dashed, and that point's right on the line, it's no longer a solution, okay? Now, let's look at one more example here. Or a few more examples, actually, because I think there's some other ones that you guys might get a little stumped on. All right, so how about this guy? All right. Again, think about these the way you would graph. In a normal situation, like this was just equals, right? If that was equals, well, you would say over here to the right, the starting point's 0 because it's not written. So that means I would start right there in the middle at 0. Okay. Then I would go up to, actually, let's make this a different number. Let's go like, I don't know, 3, whatever, right? So it's 3. So now I go up 3, 1, 2, 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1, and down the other one. All right, easy peasy. Lemon squeezy. All right, now we're changing to an inequality. So let's say it's less than. Matter of fact, sorry, I'm changing it up on you guys because I just want to make things different so you guys can see all kinds of different ways. All right, let's make this a -3. All right, so I got to start over. So we're going to start with y is less than or equal to -3x. Okay, we're going to start with that. Now, again, treat this like it's just an equal sign. So I start at 0 because there's no y-intercept there. For you guys that might get stumped by that. And now I go down 3 and then right 1. So down 3, right 1, down 3, right 1. All right. And I create my line. Then I got to decide, is it solid or dashed? Well, if it has equal to, I make it a solid line. So I just leave it like that. Then I got to decide where to shade. Now it says y is less than or equal. So I'm going to shade below the line. But now in this case, the line is leaning this way now. It's leaning the other way. So if I'm looking for where below the line is, well, below would be over here, right? So that means I'm going to shade on this side of the line. And that means all my solutions are all on that side. IXL, click the button, and you're done. All right, let's look at another example. Now, what if it was said y is just less than 3? Actually, let's not even go there yet. Let's just say it was less than 3 equal to x. Well, it's very similar to that problem. Same thing. Start at 0, but now your slope is 1. It's just not written there, right? So start at 0, up 1 over 1, up 1 over 1. And then solid line. Okay, y is less, shade below. Okay, so sometimes as long as you have a variable here and a variable here, you're still going to have a starting point, a y-intercept, and then a slope. Okay. All right. Now, what if I have this? Y is less, or actually, let's go greater than 3. All right. I want you guys to notice the difference. Actually, let's make that a -3, just so they're the same number. All right. This is not the same line as that. They are not the same line. Let me get rid of that. Notice how this has an x, it's -3x, and this is not. This is just 3, -3. This is a different kind of line. This line is a line with a slope and a y-intercept, and it goes down at an angle. Because this is just y, this is a flat horizontal line. So horizontal. Horizontal. You guys see that? Yeah, you can see it. Okay, so if it's horizontal, that means it's on the y-axis. So I start at -3 on the y-axis, and then I go straight across. Now, when you do IXL, you need 2 points, right? So you're literally just going to click here and then anywhere along that line. So let's say I click there and then it'll make your line. And then this is going to be dashed because there's no equal sign. So then I make a dashed line. And remember in IXL, you just click the line and it changes it from solid to dashed. And then it says y is greater, which is above. So these are pretty easy. It's just either on top or below. I shade up there. Okay, so my answer, my solution is somewhere up there, or it could be anything up there. Okay. Now, another example you'll see is it might say x is greater than or equal. Now it just says x. There's no y, it's just x. Well, this is kind of the opposite of this kind of line. This is a vertical line. Okay, so this goes straight up and down, vertical. All right, but what's different is you don't start on the y-axis like this one, you start on the x-axis. So I'd start on this line. It's at +2, so I go to +2. And same thing, since it's straight up and down, on IXL, I would just put another point anywhere on that line. And this one's solid, so I go straight up, straight down. And now the question is, where do I shade? Because if it's straight up and down, I'm either shading to the left or I'm shading to the right. So think about it over here, right? This looks pretty similar, right? Look at that. They're almost like the same type of question. Except instead of it putting on a number line, now it's going on a graph. But it's the same idea. If x is greater than, I'm shading to the right. If x is less than, I'm shading to the left. So same thing here. X is greater than, so I shade to the right. And if you want, when it's just the x, the one that's x, you can use the shortcut and say, oh, it's pointing this way, so I shade that way. Okay, but just for the x, all right? I don't like to use shortcuts because sometimes the shortcuts don't work. All right, like in that situation. But if you like shortcuts and you can remember the special situations, it's fine. All right, so those are the special situations you're going to deal with, okay? So you're going to have a line with slope, most likely. Something like this. Or something like this. Or something like this. Okay, or something like that. All right, or something like this, or something like this. All right, so if I change that one to this, if I go now less than, you just shade on the other side. Okay, now you would shade to the left. All right, so here with this one, it would be a line going like this. Y is great, and it'd be dashed. I shade above. Here, this has a slope because there's an x there, but we just can't see that y-intercept. So this would be solid. It says y is less, so it's shade below. This one, this also has a y-intercept and a slope, so it'd probably be a little bit steeper. Okay, and this one says above, and if it's leaning this way, above is over here. Okay, remember if it's leaning the other way and the slope is negative, now above's on the other side. Okay. Y is less, that one goes straight across because there's no x, and y is less. And it's a solid line. And anytime it's just x, you're going to get vertical lines. If it's less, shade to the left. If it's greater, shade to the right. Okay? So where are we at? Okay, so I'll just show you a couple examples on IXL and then we'll call it a day. Okay? If you guys got questions on that, please let me know. I'm going to switch cameras. No. Uh-oh. Wait, we're all still here. Let's line this up so these are right next to each other. That way we can show this right side by side. Okay, so y is greater than -6. So again, there's no x here, so it's straight across. Remember, you just need 2 points. and there's an equal sign. So like I told you, if you have that equal sign, it's a solid. Okay, and then the last part is you look at the sign and it says y is greater. You can see it's kind of pointing, this way, and greater than is going to be shaded above. So then I just click up here to turn that on. Okay. Now you can see that we went from horizontal lines. Now we have an x over here. So now you have a slope and a y-intercept. And remember, if you don't have a number over here, it's pretty much just 0. So now I start at 0. The slope is up 2 over 1. Click. Now I got to look at the inequality sign, and it's just less than. Just less than is a dashed line where I shade below. So click on it to change it to dash. And now you guys can see it's kind of leaning to the right. So that means below is up to the right. Okay. Look at a couple more examples. All right, so here's a similar one. Y-intercept is 0 again, because we have an x over here, so we have a slope and a y-intercept. Start at 0. This time go up 4 over 1. And again, it's dashed because there's no equal sign. And this time it says y is greater. Now it's leaning to the right. And as it gets steeper, it gets a little bit harder to see where above is. But it's leaning over to the right. So if it's leaning to the right, that means above is over on this side, to the left over here. And if I were to shade on the right, that's below. So this would be like a less than area. So I want to shade on the left. So if you're like getting stumped by these, I know often what happens when people are getting stumped by these is they're like, it looks exactly the same. It looks just like the graph that, that's the correct answer. Usually what it is like the dash, you're not doing a dash or solid line correctly. Or let's just say I'm doing this problem, and here I have a y-intercept at 7, and now it's negative 4x. I go down 4. Right 1. And sometimes what I see is people accidentally just go like an extra square. So when you compare your answer to like the correct answer, it looks the same, but maybe your slope's just a little bit off, but it looks really close. So make sure you're counting right. All right. So here I should be going down 4, not 5. And that's it says equal to, so I want a solid line, so I'm good. But then it says y is less. So now the line is leaning to the left side. So because it's leaning to the left, below is to the left. Okay, below the line. So now the solution can be anything in that shaded area. Okay. And as you go up, the questions are pretty similar after that. I believe you only have to get 60 on this one. 65. Okay. So you shouldn't see a problem like this. I know some of you guys like to, go to 100. And that's fine if you want to do that. If you're trying to go to 100, what you have to do with this is put it in y equals mx plus b. All right. So just a quick demonstration on how to do that. If you guys remember, you have to rewrite the equation. You have to go minus 5x here. You got to do that basically on both sides. Because what I'm trying to do is get the y by itself. Okay. So now I go y is greater than or equal to negative 5x and then minus 2. And you don't add these two numbers. It doesn't become negative 7, so just a reminder because those aren't like terms. Okay. Then you would basically just graph this. All right. So that's what those problems look like as